Now that we've learned a few simple definitions, let's learn a few more. There are basically two different ways to write a set. One of them is called set roster notation. Roster notation. And by the way, when I'm defining terms, I usually underline them. Roster notation is essentially just listing all of the elements out. For example, A is equal to 0, 1, 2, 10. I didn't write them all out, but this ellipsis saves time. But it is a list, and you know what the implied list, all the numbers are, that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Excuse me. Capital B equals the two colors, black and green. That's it. That's the set. We listed them. The more commonly used one, especially when you're talking about a large number of elements, is called set roster notation. I'm sorry, set builder notation. Set builder notation uses a proposition we'll call P of X. A proposition is just a true or false statement. That's all it is. And it's based upon a variable X. So let's take a look at some examples. And note, as it said here, X is in the set if and only if P of X is true. So if P of X is true, X is in the set. If P of X is false, X is not in the set. Here are two sets that are written in set builder notation. Capital C is the set of all X, and then this colon, you use the word such that, the set of all X such that, and then this is the P of X proposition. It's either true or false for every single value of X. The set of all X such that X is a real number and X is bigger than 0. So another way of saying this one in words would be the set of positive real numbers. And I'll make a note that this is frequently, the fancy R is the whole number line, all of the real numbers. And if you put a plus up there, it looks like an exponent. It's not. That means the positive real numbers. And then a very simple set builder notation would be the set capital D is a set of all Y such that Y is equal to 5 or Y is equal to 10. That's actually a long way of writing it because we only had two elements. We should have just used roster notation and said 5, 10. And just as an observation, frequently when we're talking about real numbers, I might write the set C in a slightly different way, using all the same letters. I'll say the set of all X in the real number, in the set of real numbers, such that X is bigger than 0. So you can put a little fact in here, a little factoid before this colon. You could say the set of all integers such that the integer is something. Here I said the set of all real numbers X such that X is bigger than 0. All right, well, let's look at some more sets that we're going to use throughout this class. More sets. Well, I already talked about this one. Z is the set of integers. I'll write it out one more time. Notice it takes two ellipses. It takes one here because it goes forever in that direction and it goes forever in that direction as well. So Z is a set of integers. N is, this fancy N is the set of natural numbers. The natural numbers start at 1, 2, 3, ... So the natural numbers are all integers, but they start here, 1, 2, 3, ... You could call this set of natural numbers just the positive integers. How about this? We already saw this one. The set with no members is the empty set. And you can write it this way, brackets with nothing in it, or this symbol right here. intervals are sets. If you don't remember what intervals are, I'll give a brief description, but you may want to go back and look in one of your old textbooks. Okay, so for the real numbers a and b, where a is less than b, we have the following intervals. It's all of the real numbers in between a and b, and including a and b. So this, written in set builder notation, would be the set of all x, and maybe I'll say the set of all x in the real numbers, because a and b are real numbers. The set of all x such that x is in between a and b. So a and b are both in this set, and every number in between a and b is in the set as well. This is what we call an open interval. We call this a closed interval. This is an open interval. The set of all x in the reals such that x is strictly in between a and b, which means it can't equal a or b. And I don't want to write out all of the possibilities, but I will do, say, 3 or 4 more. This is called a half-open interval. It's open on one side, closed on the other. This is open on one side, closed on the other, and I'm sure you can figure it out even if you haven't seen intervals before. This is going to be x in between a and b, but the square bracket side gets a less than or equal. It can be a is in that set, b is not. In this one, a is not in the set, but b is. And I guess I should do 2 more that involve infinity. Hopefully you've all seen this symbol. Oops, that's not very good. It's almost like a racetrack. The infinity symbol, well, that's a positive infinity. If you take something like that, this means all of the numbers from a all the way up to infinity. Infinity is not really a number. Notice you can't put a square bracket on the interval where there's on the side where the infinity is. Infinity is not a real number. It's basically a symbol that is something larger than every number on the real line. That's a way to think about it. So this is going to be the set of all x. Set of all x in the real numbers. And you just have to say x greater than or equal to a. That means a all the way to infinity. So on the real line, you've got a, and if you were shading it, it represents all of that region. Infinity is out beyond. You can think of it as being out beyond the real line, and negative infinity on the other end, in the other direction. So if we take negative infinity up to b, and I'll put open on both sides, that's a set of all x in set of reals, such that x is less than b, strictly less than b. It's going from negative infinity all the way up to b. And that's the definition of intervals. I covered most of the cases. I didn't put an open a comma infinity. I didn't put a closed over here. But just remember, when you have infinity, it's always in this position, not the first one, because the smaller number goes on the left, the larger goes on the right. And when you have negative infinity, it's on the left, and you always use open parentheses on the infinities.